everyone. Welcome
Yes.
to our session on Distributed Data Lakehouse. Are you building one? We are from Alluxio. My name is Jasmine. I run the open source community as the head of community, as well as developer relations. And my partner, David Zhu, is a tech lead manager, as well as a open source PMC member of the Alluxio open source project. There is a fast-growing data industry that has led to a fragmented data solutions and unprecedented complexity of the data platforms. We've seen data silos across all data centers, regions, and clouds. There's more people and teams that needs to access and leverage these data. And we've also seen new compute and storage technology created every 3 to 8 years, which resulted in multiple data copies and then synchronization costs, multiple data APIs, necessitable integration and application rewrites. And all those environments also have very different environment properties. So with that, there is a strong demand for a more simplified solution that can provide a unification of data lakes, efficient data access, and management. And this solution should also be environmental agnostic. And that's when we introduce Alluxio to you. So Alluxio as a product, it is a large distributed system that is a new layer between the compute engines and the storage systems. This layer provides a complete virtualization across all data sources to serve data to applications who do not need to worry about the location of the data. And the solution is applicable across all environments, whether it's in cloud, on-prem, bare metal, or containerized. Alluxio actually started as an open source project back in UC Berkeley's AMP Lab in 2014. Back then, it was named called Tachyon. When we pivoted to a company, we renamed it into Alluxio. So now after 7 years, we now have a very large and vibrant open source community with over 1,200 contributors and start growing, and more than 9,000 active members on the community Slack channel. We're also recognized as a top 10 most critical Java-based open source project by Google and OpenSSF. We also named as one of the most valuable repositories on GitHub. As a head of community, I sincerely want to welcome you, invite all of you to join our Slack community to see, check out our community and see what we have to offer as a member. There are actually 2 versions of Alluxio. Like I said, since we built the open source version, that's called Community Edition, free for all. And then also there is an Enterprise Edition, EE version, that helps the company to generate revenue. As a product, we have seen thousands of organizations using Alluxio. We've also seen success across different verticals, with technology company leading the way. There's also more regulated markets such as financial services, pharmaceuticals with stricter security needs have also adopted Alluxio.
So, as Jasmine mentioned, Alluxio is a layer that sits between your compute and storage. And many of us are moving towards cloud storage these days, but cloud storage does not come cheaply. Storage might be cheap in the cloud, but access is actually very expensive. Traditional cloud vendors have adopted a pay-per-use kind of model, so that each time you access your data, you will pay for both metadata and data access. And Alluxio will liberate that data and allow you to make the most of your data that's stored in the cloud. So here's a picture that describes how Alluxio can be used to save cloud storage cost. And here you have data stored in AWS, Google Cloud, and perhaps elsewhere on-prem. Alluxio sits between your compute and storage layer. It caches your data dynamically so that you're not repeatedly paying for access to the storage in the cloud. And this is also agnostic to your compute engine. So whether you're using Spark or Presto or some AI framework to operate on your cloud data, you can use Alluxio transparently. In addition, Alluxio is also a platform to allow you to access heterogeneous data across many different sources. So whether your data is stored in an NFS mount or a cloud vendor or your on-prem proprietary storage vendor, Alluxio can pull that data out of the data silo and provide it transparently to your application. So here I will describe one of the core features of Luxio, which is distributed caching. In this picture, you can see there are 3 different computer frameworks: Spark, Presto, and TensorFlow. They all make use of the same set of data, and perhaps you have a data pipeline that first does some ETL jobs in Spark, and then perform some queries in Presto, and in the end you do some model training in TensorFlow. But it's a pipeline, so what Alluxio allows you to do is to cache the data that is in the intermediate stages of these pipelines, so that you're not repeatedly writing and reading from the object store. As we all know, writing and reading from the object store is very expensive, so Alluxio significantly cuts down on the cost to access your data. The second core feature of Alluxio is the file system namespace virtualization. So as many of you know, many problems in computer science can be solved with a level of indirection, and Alluxio is no different. So when you are accessing your data in the cloud, you're describing the location of the data. Typically, that is a physical location of the data. So for example, if you're accessing data in AWS, you start with s3://. If you're accessing Azure data, you would use a different protocol. But with Alluxio, you're using the same protocol to access your data. It doesn't matter whether the data is in AWS or Azure or GCP, you're using the same protocol to talk to your data. So it hides that physical location of the data from your application. And as a result, your application writer does not have to worry about where the data is, how much it costs to access that data. It comes naturally to the application writer. It's a more natural interface for them to operate on. And of course, it will make them more efficient as well. So Alluxio provides many different flexible APIs for application writers. We first worked with Spark. So as you can see here, you can just plug in Alluxio:// into a RDD, and you can operate on data that is sitting provided by Alluxio. And with Presto, you can specify a location that is pointing to Alluxio. Alluxio also provides POSIX interface through Fuse implementation. So you can use all your favorite Linux tools to display data that is cached in Alluxio. Of course, being a Java project, Alluxio provides a Java native interface. So you can use a file stream type of interface to read your data from Alluxio. And as S3 is becoming the standard protocol to access object stores in the cloud, we also provide compatible S3 compatible interface for application writers. So in this example, you can use AWS client to point to an endpoint that is essentially an Alluxio server, and you can access Alluxio data through an S3 API. So here's the reference architecture of Alluxio. On the left side, you have the applications, Presto and Spark. And on the right side, you have what we call understore. It can be an object store or HDFS. In the middle sits Alluxio. So Alluxio typically comes with multiple masters. That is for high availability purposes. And we use Zookeeper or Raft for leader election purposes. And then as Alluxio scales, the main scaling component is a worker. So you can add as many workers as you need to fit your working set in Alluxio. Next, I will describe 3 use cases that kind of covers a very wide spectrum of different usage in the Alluxio community. The first one comes from China Unicom. It is a very traditional ETL kind of pipeline on Spark. The second one is Expedia. They're using Alluxio for multi-cloud deployment and using it for cross data center compute. And the third one comes from Microsoft. They're using Alluxio to do AI training in the cloud environment. So the first example comes from China Unicom. And in this picture, you can see it's a very traditional ETL kind of workload. You're writing some data into Alluxio and then reading it back out from Alluxio. Before Alluxio, you would write this data into an object store and read it out from an object store, which can be expensive. It can be expensive in terms of cost and expensive in terms of access speed. So after they changed to Alluxio, added Alluxio into their architecture, they actually saw a 4x performance improvement with Alluxio. So their average query performance improved by 4x, went from 2.1 minutes to 33 seconds. And this is because Alluxio cache was large enough to hold their working set of data and reduce access to the underlying object store. The next example comes from Expedia Group. As many of you know, Expedia has acquired many other companies during its growth period. And as a result, its infrastructure is very heterogeneous. So that means it has lots of data sitting in many different locations, perhaps using different protocols. So here they're taking advantage of using Alluxio to provide a uniform way to access their data. So Alluxio sits in the middle between their applications and their data platforms. And it doesn't matter whether the data is in AWS East or West. It doesn't matter where the compute is, as long as Alluxio is co-located with the compute, can provide caching capability to the compute frameworks. And because Alluxio reduced the number of accesses to S3 object store, their queries are now actually 50% cheaper. The last example comes from Microsoft. In this particular case, they're using Alluxio to speed up their AI training workload. So this is an architecture describing their AI training workload, and they have NFS and Alluxio. And they also have data sitting in Azure Blob Store. So here's the performance numbers for their ImageNet training process. So with Alluxio, you can see it scales linearly as you add more compute capacity. However, before adding Alluxio, it quickly stops growing. The performance quickly stops growing because it's communication bound, right? So Alluxio allows the compute to continue to scale when there's when you add cores to your system. So here are some takeaways from these use cases. Alluxio caching can provide cost saving and faster access to your data. And long-living cache scales independently of your compute resources. So you can add and remove compute resources, but leave Alluxio cache alone. And that's kind of from yesterday to today to tomorrow, the cache will stay there and continue to help your data access. It doesn't come and go with the compute resources. The third point is Alluxio allows multiple interfaces so that your application writer has the flexibility of choosing the most convenient interface to talk to Alluxio. Last but not least, Alluxio provides this unified namespace. So it separates the physical data location from how you address your data. This flexibility allows you to dynamically change the physical location of the data depending on cost or access pattern without changing the application code. So finally, here are some links to our website and Slack. Welcome to join the Alluxio community. Thank you.